Good morning, good afternoon, good evening, wherever you're hailing from. Welcome to another episode of OpenShift Administrator Office Hours on OpenShift TV. I am Chris Short, executive producer of OpenShift TV. I am joined today by two of my fellow Red Hatters, the one and only something of GitOps, Christian Hernandez. I'm not sure what to call you yet. I'm not sure what you want to be called, but we'll get.
It's still pending. Yeah,
it's still pending of GitOps.
I'm taking votes.
And then, as I referred to him in an internal email, the role of Andrew Sullivan today will be played by a what is it, otter sounding but smoother carbon-based life form.
I can't remember exactly what you used. I'm not sure whether I'm offended or not.
Yes. So like better sounding, like different sounding,
Okay.
but like, smoother, right? Like, so yeah. So, but to be honest, Andrew's off helping one of our customers right now, and we are talking about something that Reese is. Well, Reese, introduce yourself, and then we'll get to what we're talking to real quick.
Yeah, thanks, Chris. So good morning, good afternoon, good evening, everyone. My name is Reese Oxenham. I am probably as surprised as you are to be invited back again to deliver another session. We are going to be going through the assisted installer, which is something that I've been working on considerably, and we're going to go into that in a lot more detail. I'm going to try and do a live demonstration of this, and all being well, doing it on real bare metal systems, so there's going to be a little bit of a delay in a few different areas, but yeah, it's some exciting stuff.
Yeah, no, like I can't wait. And if everything hits the fan, I have a nice clean server across the office here that we can use this thing for.
Sure, sounds good. I got 3 bare metal machines that we're going to try and deploy OpenShift on today using the assisted installer. So beautiful. I just wiped them. Let's see how we get on.
All right.
Well, let's get to it. Let's do it.
All right. Sounds like a plan. Let's
just jump all over it. So what is the goal of the assisted installer, basically, Reese or Christian? Either one of you can answer that question, I guess.
Yeah, I'm happy to give a stab at what as I would explain it. So sure. We have tried for a very long time to make the consumption of OpenShift, a very good experience, right? We know that customers are looking to deploy OpenShift across a wide variety of footprints, be that on top of virtual platforms, be that on top of public clouds, private clouds, whatever they are. But we also know that a lot of customers are looking at deploying on top of bare metal. There's lots of reasons why customers want to deploy on top of bare metal. Whether it's what they have particular requirements for their applications, be that performance, or they maybe want to exploit underlying implementations like GPUs or FPGAs, whatever it might be. And so we have to also make OpenShift really, really consumable on top of those platforms. We have a number of different investments around things like the bare metal IPI implementation. So, automating the infrastructure right the way from the ground up. But we want to go that little bit further and make it even easier to deploy an OpenShift cluster. And we're doing that in the form of a web-based utility, which I'm going to show you. You can see it live in action for driving all of that, right from bootstrapping the machine up, deploying OpenShift, sharing everything you need.
Hopefully with DNS records, as Carlos Santana points out.
Yeah, we'll go into that a little bit.
Yeah.
So Christian.
So my quick question, I guess, my open-ended question is here. The differences, or how would you categorize the bare metal IPI versus the assisted installer, right? Because there is there's some overlap in terms of like the technologies we use in both situations. So when would you use one over the other, or what are the major differences?
The nuances here,
Yeah, so actually the way, or the resulting cluster at the end, is almost identical. So a cluster that you deploy with the assisted installer looks and behaves in the exact same way as a bare metal IPI cluster would. The main difference for me is just ease in getting that set up and getting it up and running in the first place. So with bare metal IPI, You have to find a system that you want to run the OpenShift installer on, just like you'd be deploying on top of any infrastructure, public cloud, VMware, Red, OpenStack, whatever it might be. You then have to tell it, well, these are all my nodes that I want you to use. You have to fill out the IPMI, out-of-band management configurations, usernames, passwords. You need to make sure your OpenShift installer machine has networking access to those machines so that it can provision them, run the Bootstrap VM on top of them, and so on. Whereas the assisted installer requires nothing but the ability to attach an ISO to the machines. You power them on manually through the out-of-band management platform. They provision, create a cluster, and away you go. There are very minimal requirements to getting this up and running. And the beauty of it is that you can do it all via the web UI. You don't have to download and run the OpenShift installer or generate your own install config. Everything is done inside of a web UI.
So literally assisted. It assists you
Yeah.
each step of the way versus
Right.
The regular IPI method where you have to download the CLI, and then you have to kind of pretty much prep everything beforehand. This literally assists you in each step of the way.
Yeah, exactly. And a lot of the benefits will just become apparent as I show it. And perhaps I should just start sharing my screen, and I can actually show you it live.
Yeah.
Let's
Is
spin the tires on this puppy. Yeah, come
absolutely.
on.
There's an expression here in the US. I don't know if you've heard it over there in the UK, but this is, I think Chris Short's in the show me state, right? It's like we're in the.
No, I am not in the show me state. That's Missouri.
Oh, Missouri. I always thought it was Michigan. Okay.
No, I don't even know what Michigan is. What is Michigan's thing?
What is Michigan? The glove or something?
No,
like
Michigan is pure Michigan.
Pure Michigan.
I think
gotcha.
that's a thing like now, right? But there's like a longer version than that somewhere. Yeah.
Cool.
I've worked for Red Hat for coming up to 12 years now, and had the pleasure of working with a lot of different Red Hatters from all over the world. I still cannot keep up with all the various different Americanisms in use.
Americanisms.
Yeah, there's a lot of expressions. Yeah.
Yeah, we're not shy.
No. All right. So the beauty of the assisted installer is that it's now directly integrated within cloud.redhat.com. So this is hosted by Red Hat. You don't have to download and install anything on premise. It is just out there. It's all SaaS sort of based. Now I'm inside of my login to this. It's just my employee account, and it's got a whole list of various different clusters deployed across the world. Now you're seeing lots of clusters here just because I'm part of an employee group. We can ignore these for now. Now, all I'm going to do is I'm going to create a cluster. And at this point, it's agnostic, right? It's not going down the assisted installer route yet, but I will show you how we get there. So I just want to deploy OpenShift Container Platform. I'm not going to deploy OpenShift Dedicated here. This is just an employee environment. And like normal, it's going to ask, well, where do I want to deploy onto? Public cloud platforms that we support inside of my data center, or indeed on top of my laptop. Now, the entryway or the path to getting into the assisted installer is to say run on bare metal. So I'll hit that, and this is where we get the two options. You're probably expecting to see three options here because we've talked about that third option, that bare metal IPI infrastructure. That is, that's not a fully supported mechanism right now. That's still in the dev preview or technology preview realm. It can be used, but it's not yet supported. That's why you only see this user provisioned infrastructure path here and the assisted bare metal installer. So this is how you get into it, and this is where you get into the pipeline of deploying the bare metal cluster with the assisted installer. All right. So this is where it's just going to ask us a number of different questions about what it is that we're actually deploying here. Now, you can run through this, and this is where we can start talking about DNS and the requirements from an external perspective. The assisted installer has very, very minimal requirements when you're deploying an OpenShift cluster using the tool. you can deploy into an environment that has DNS already set up, or it can work in a way where it will host all of the various different DNS internally, and you point your Etsy hosts directly at the cluster. So I do have inside of my environment partial DNS configured. So when it comes to setting up my cluster name, I want it to match what my DNS domain name is inside of the bare metal infrastructure. And what we'll see if I jump over to my jump host, all of my machines, I'm not sure whether you can see it. These are all, it's an internal address, but pemlab.rdu2.redhat.com. So I want to make my cluster basically match this DNS domain name. So when I go to, sorry, go on,
yeah,
Christian.
Yeah, so quick question. Where is this? So you said that you can deploy this on a pre-existing like DNS, right? Like as in what you have, right? Like I have my own DNS server.
Yeah.
Or you can use Etsy host. Where's that sliding scale? How much can I have something like in the middle, right? Can I have like a hosted DNS somewhere else, or what's that sliding scale in terms of what's allowed?
So right now, because we follow the bare metal IPI path, the cluster itself holds or manages internal cluster DNS for everything it needs. It also manages the ingress and the API VIPs itself. So we have no requirements from an external, perhaps a helper node or external infrastructure to manage the DNS or the load balancing or the VIPs. We self-manage all of that inside of the cluster itself. That solves for the cluster, right? But obviously I, as an administrator, or my clients, they need to get access to it as well. So what you can do is you have a number of choices. You can either update your corporate DNS afterwards to point at the IPs that the assisted installer used. Or you can update your Etsy hosts, and that's what I'll do at the end of this, just for convenience and to show you how it works. But right now, there's not really a sliding scale where you can say, well, no, I don't want you to do that. It's kind of, that's the way it works. And after deployment, you can choose to make it easier for your clients to access the cluster by using the IPs that the assisted installer used. And you can define them if you want to, and I'll show you how you define them. But yeah, it's not really a choice.
Gotcha. So it this uses the same mechanism, let's say, as like vSphere IPI or OpenStack IPI, where the MDNS kind of just takes care of the cluster itself, and then as a day 2 task, let's say, or even like now as a day 1 task or a separate task, you can point your DNS to this cluster.
Exactly right.
Yeah. So Carlos Santana is asking for like a drawing diagram or something. Like, is this inside of VPC? Whatever. Like, maybe you can talk about that kind of infra layout. But then he mentions that like infrastructure will never let you edit corporate DNS. So this is kind of a good thing, right? Like,
yeah. So we're not suggesting that the installer will expect to update corporate DNS dynamically. What we're saying here is that the assisted installer will allow you to choose the IP addresses you want to use, and it will host basic DNS in the environment. So if you point at it, with an Etsy host override, it will all work out of the box. But if you have the ability to, for example, you could ask corporate IT, well, I want 2 DNS records, one for my API, one for my ingress, and you tell me what IPs I can use, you can set those inside of the assisted installer, so the cluster uses those addresses.
Nice. So you don't even have to worry about DNS for the first little bit if you don't want to.
No, you don't at all. So long as the cluster has IP addresses that it can use, you're good to go.
Nice.
Yeah. Let me just talk about, before we proceed with this, let me just briefly talk about the environment that I am using. And I appreciate it's a little bit small. I did my best to to blow this up.
We
We're
did
sort of in a bit
try
of a
to enlarge in this.
No,
That's why we were running a little behind with the show today, was trying to figure out how to make this screen bigger.
Yeah, indeed. So the assisted installer, as I mentioned, it's really designed for bare metal clusters. You can use it for virtual clusters if you want. It really doesn't matter, but it's really designed for the bare metal path, because that's typically the more difficult configuration to bring up for obvious reasons. Inside of my lab, I just have 3 bare metal machines. So we're really looking at deploying a converged worker and master configuration. So the nodes are simultaneously, all roles. This is not a sort of typical production type configuration, but it does suit certain configurations that I know that we and our customers are looking at. You can think of small footprint edge type configurations where we really want to minimize that footprint. So it just sort of proves that there's a bit of flexibility in how we deploy OpenShift, and I'll go into some of that flexibility in the next pane. But the idea here is I just want to show you how we would use the assisted installer and how we would get these machines provisioned using it. Because even though we try and make it as easy as possible, there is a little bit of manual work involved in bringing these machines up. So we'll jump between this window and the next. And don't worry so much about the fact that you can't see some of this text. It's more of an implementation detail. I'll tell you exactly what I'm doing.
Yeah, so even though it's sort of automated, you still need to have your out of band set up beforehand. Like, it just doesn't magically have your out of band all set up for you. So
exactly. And all I've got here is it's just a jump box that I'm using to allow me access to these machines, and also as we'll explain how we use the ISO to provision them. All these machines, they're currently in the Raleigh area. I'm in the UK. If I was to attach a virtual media ISO to all of these machines from my machine, it'll
take a while.
Yeah, it'll take a while.
Those bits it will take a while to go over the pond.
Exactly. All right, so let's get into it. So because I want to somewhat match the DNS environment that I currently have in my environment, I'm going to call this PemLab. It's just the name of the environment. OpenShift version, we can only select 4.6 nightly at the moment. So this is a nightly build. We're not using, it's obviously pre-release bits at the moment. And the really cool thing now that this is integrated within cloud.redhat.com is that it already knows my port secret. So
yay!
Yeah,
no more copy pasta.
Exactly. So that's already in there because it's associated with my account, which is really, really convenient. So I'll go ahead and click save and continue. And what we now have is an additional pane, and there's lots of different options in here, and we're going to go through these. But the first thing it's going to tell us to do is to generate a discovery ISO. Now, this is the clever part. When I want to add my machines to this potential deployment, I simply need to provision them using a discovery ISO. We attach the ISO over the virtual console, virtual media interface, or whatever it might be, or as simple as you could burn the ISO and attach it using a real CD-ROM if you really wanted to. But the fact is, these machines, they only need to come up with this discovery ISO. They then connect back in to cloud.redhat.com using this dynamically generated, generated just for this cluster ISO. They appear here, and then we can configure it all and tell it to kick off the installation directly from here.
Yeah, someone just mentioned in the chat that out of band is technically optional, right? Because you can literally, as I joked on the chat, is you can literally burn this to a DVD or a CD and have the intern go and boot it off of the CD-ROM or DVD-ROM drive.
Yeah, and there's also no reason why you couldn't create a USB key.
Correct.
Right.
With the same ISO.
Or spinning disk, whatever you wanted.
Whatever you wanted to do. All we need is to get the machine to boot this ISO.
Series of floppies, whatever you want, right?
100,673 floppies.
Yeah, exactly.
Whatever floats your boat.
Exactly.
So, all right. So there's a few additional things it's going to want to ask us now. First of all, SSH public key. Now, I'm just going to put my key in. The benefit of this is that if these machines have any problems booting up, or they can't access this console, perhaps there's a networking issue somewhere, perhaps a DNS issue, because these machines, they still need to be able to connect out to the internet. They need to reach cloud.redhat.com. They need to pull down container images. So there needs to be basic DNS inside of the environment, but we don't have to worry about full DNS already pre-established in the environment. As I said, the environment will take the OpenShift cluster will manage the core DNS of the cluster. This is, hosts must be connected to the internet to form a cluster using this installer. Each host will need a valid IP address assigned by DHCP, right? So obviously it needs an IP, it needs to have a route to cloud.redhat.com, so the DNS capable for that. And crucially, all machines need to be on the same layer 2 network. Now this is again because the cluster is self-managing all of its virtual IPs. Those virtual IPs have to be on the same subnet and same layer 2 network. Right. So okay, SSH public key. I'll just pull this in. Oops, daisies.
Oopsie daisies.
Oopsie
that you say
just slipped out.
My son says that.
That's right.
And my son says it because it's a Midwestern thing.
It is.
But
look at that.
Yeah,
well, I guess
but you're not Midwestern.
Apparently it's maybe it's an English speaking.
Maybe it's an old English
anyone
thing.
From Australia? Where's August? Maybe he'll.
Exactly.
Where's August? Maybe he's still sleeping probably.
Yeah. 23-hour time difference or whatever it is. Yeah.
All right. So this discovery ISO is now ready for me.
What's really cool is they give you the wget command, or
like you can just go grab it.
Yeah. Or the S3, the S3 bucket where you can just, you don't have to.
That's slick.
Yeah, it's pretty slick.
Yeah, exactly. So it throws it into an S3 bucket. It's ready to go. I can copy it there. The one bit I did just gloss over accidentally is there was an option that if I have a HTTP proxy inside of my environment, I can set it before it generates that ISO. And so when my machines come up, if they need to use a HTTP proxy to access cloud.redhat.com or any of the container image repositories, you're good to go.
Yeah.
So I'm going to copy that. Now, again, I'm not going to use my browser here to attach to the machines. I'm going to dive straight into this machine here. And this is my jump host. I'm going to download this.
Is this the jump host on the terrible box with the bad font? Or can we increase the font here?
Oh yeah, we can increase this.
Thank you.
Yeah, all I'm doing, I'm just downloading, because this machine for some reason doesn't have wget, and I could have installed it, but I'm used to just using curl. Output and discovery ISO. And
libcurl's a thing.
Yeah. And this shouldn't take too long at all. And what I'll do then is I'm going to attach this to all 3 of the physical machines. Again, you could do this in a number of different ways. My 3 machines, they're just, they're Dell blades, essentially, little FC430 nodes. And I'll just use the virtual media interface to grab those.
Nice.
And there we are, that's done. So I'll start off with my first machine. So connect virtual media. And again, I apologize that this is likely a little small on your machine, but I'll show you exactly what I'm doing. I'm mapping a CD/DVD, browse for the file, discovery.iso, and I map that device. I'll close that. And what I will do is I will return to the Dirac console. I need to go to setup, change the first boot device, because by default, these machines will want to PXE inside of this environment. I will say virtual CD DVD, apply that. And I will then go to power/thermal, and I will power on the system. And yes, I definitely want to power on the system. And what you'll see is that this machine should turn on in a second. There we go. So this machine is now turning on. And it takes a little while, of course. Remember, it's still pulling this. It's still a real bare metal machine, and it's going to get to the point where it's going to try and boot the virtual CD ISO, and it's going to be pulling across the network. Now, these machines, this jump host that I'm using is in the same rack. It's a VM inside of the same rack, so it shouldn't be too bad. Certainly a lot quicker than pulling over the Atlantic, but it still does take a little while. So
Pulling
what I'm
over
going
the
to
Atlantic sounds like a police term.
Yeah.
So I'll leave this one go. And what I'm going to do pretty quickly is just do the exact same on the other 2 machines. So I'll connect virtual media, and again, I'll just do this quickly.
I remember when the out of bound management first came out, and I thought I was like, this is a game changer. I don't have to run down to the data center every time.
Yeah, I don't have to insert something. Yeah.
Yeah, exactly. I don't have to take the golf cart over to
right. Yeah. I remember those days. Fondly.
I have to go to the data center too. So one of the
servers
servers is
I'm off to the backup data center. I'm off to the primary data center. Does anybody need anything?
Yeah, exactly. Yeah, exactly. Well, I'm there because I'm only going once.
right. I'm not coming back.
All right, now just this last one.
Nope.
Timeouts.
Kicked you out.
That happens.
So you can see, IPMI boot to virtual CD requested. That's expected. And the last one, boot the virtual CD DVD. Power.
So in the when it generated the ISO, it essentially it embedded all these all the options it needed.
Yeah.
For the install.
And it's actually kind of basic. It doesn't embed the install config because there's still additional configuration options we need to go through, but it's enough so that it knows when the ISO comes up, and you'll see it's just a CoreOS image. When that comes up, it connects out to the installer and the assisted installer pane, and it allows you to then set the rest of the configuration, and then we can actually say, well, install a cluster now, and away it goes. But we'll see that happen in a few minutes. All right, so now it's loading the kernel. It's going to do the RAM disk and the ignition config as well. But this is unfortunately going to take a little while, just because of, again, bare metal machines, and indeed, see this is RHEL CoreOS, and because we're pulling all 3 of these ISOs at the same time. Sorry, the same ISO to 3 machines at the same time.
That might be labor intensive on a network.
A little bit.
Or depending on the hardware, right? I would imagine.
Yeah, it's also, it's pushing all this through a Java interface.
Oh, that's right.
Right. Yeah.
Yeah, I forgot there was a time where everything was written in Java.
I forgot about that.
Yeah, I forgot about that. Like, well, even vSphere now, they just deprecated. Like now they're all going HTML5. They just deprecated the Flash, right? So they went from.
I remember when the HTML5 stuff came out, like it was like 5-6 years ago.
Now barely everything is barely starting to move over.
I actually think this is HTML5.
Is it?
So okay. Maybe I'm.
Maybe you are. So
maybe I'm just wrong.
Anything's possible.
Indeed. So yeah, you're going to see these 3 machines. They'll eventually now boot up into the CoreOS image. And what we're going to see, if I just quickly revert back to this window, I can close that now. What we're going to see is that essentially this window pane is just going to sit there waiting for these hosts to appear. So they're going to boot up. They're going to look at their essentially just an ignition config, which defines exactly what the machine needs to do. It needs to start, a basic sort of a container that brings that connects into this. It's going to start getting information about all of the machines that get provisioned. We can see all of the specification. We can make sure that they're the right nodes, that they have the right CPU, memory, disk, networking configuration, and we can start doing some additional tasks, which I will show you very shortly.
So there's an implicit prerequisite here, since the hosts are actually essentially phoning home, right? They are connecting to our SaaS cloud.redhat.com. there's an implicit, your servers need access to the internet, right? So
correct.
It actually needs to be able to reach out and communicate with cloud.redhat.com.
Yeah, so they need an internet connection. That doesn't have to be direct. It can be via a proxy. And that's why when we generated the discovery ISO, unfortunately, I'm sorry, I skipped over it. There's an option where you can say, well, this is my HTTP proxy. So you can provide that information and they can get out. But obviously, when these machines come up, the first thing they're going to try and do is they're going to try and DHCP. You need to have a DHCP environment in the environment that you're using so that it gets an IP address. Once it's got that IP address, obviously you're going to need gateway. Gateway will allow it to access this, but also you need to make sure that there is at least basic DNS in the environment, because when the DHCP issues the name server, that name server needs to be able to resolve not all of the node names that you're going to use inside of the cluster, not API or the ingress VIPs, just cloud.redhat.com and the various different image registries where we're going to need to pull the OpenShift images from during the installation.
Yeah, there's a question, and I think I know the answer, but I'll let you answer. It says, can you run this on premise or is it Red Hat?
Premises.
So is this hosted only, or is there a plan to like bring this into let's say I assume they're asking for like disconnected or
yeah, so right now this is only on cloud.redhat.com. Of course, like everything that we do, it's all open source. And so you can go out on GitHub and you can see how you can deploy instances of this. But in terms of a supported configuration in a sort of disconnected environment or something you just want to deploy inside of your own infrastructure, I do not know, I'm afraid. I would need to check in with the product management teams that are, it's their decision to make.
Gotcha. Well, and someone actually just mentioned, yeah, you can actually run this as a container.
Mm-hmm.
I guess that's the open source version, as you mentioned.
Yeah.
Okay.
So you can see these machines are coming up. This one's just finished. So what we should see is this one should actually pop up right about now. All being well, live demos and all that.
Yeah, and all that. Yeah.
What's funny to me is you're doing a live demo, but my computer is like super struggling right now.
No, got to put a fan on it. Buy a big industrial fan.
It is 66 degrees in my office right now. There's not much more I can do for it.
Not much you can do.
The laptop you're using?
It's like the new 16-inch MacBook Pro that Red Hat's given out. Yeah, so it's got a lot of horsepower and everything.
Mm-hmm.
I'm just doing a lot with it right now.
That's fair.
It's time to start closing things.
Yeah. Let's see what's going. Oh, as I clicked on this, it appeared. So here you can see our first node has just come up. And what we'll see is, if we dive into it, you can see some additional information about it. So yeah, it's a Dell machine, it's an FC430 blade, CPU, memory, BMC, some additional information about the disk sizes, the networking that we have inside of this machine, and detected IPs and subnets. And you'll see that all three of these machines will all start to come in. So this second one, node 12, should be our next one. And then what do we have here?
10. Oh, failed to mount.
Yeah, might have pushed this a little bit hard doing all three at the same time. Let's just reboot this guy and get him.
Oh, there you go. See, before this would have been like, oh, now I have to drive back with the golf cart to the data center.
Yeah, so I may need to ask this to CD boot again because I don't recall.
Oh no, that's Windows.
Yeah,
safe mode.
I think it's F11 on these.
Yeah.
Yeah, boot
yes,
manager,
it is boot manager.
F11. And I'll just make sure it selects the CD.
There was also a question while I know you're multi-threaded right now, but there was a question about if you can take the contents of the ISO and just boot the bare metal servers off of Pixie.
There's no reason why you can't do that.
Yeah. Okay.
Yeah.
That's not something that we provide the instructions to do, at least not in the context of the assisted installer.
Yeah.
But there's no reason why you couldn't, deliver the ISO in that format. It only runs that ISO temporarily just to get it up and running, and then we redeploy CoreOS onto the root disk anyway. So
yeah, because I mean, just in general, you can unpack the ISO. You can just mount it read only wherever you want to, and iPXE off of it. So
this is funny. Sorry. This system I did actually have a little bit of trouble with the other day. It was complaining about some kind of networking issue between
Oh, is that the thing you were talking about in Slack the other day?
Maybe. Because this is taking its time. It doesn't usually take that long. Ooh,
oh,
here we go.
Time for remote hands.
Yeah.
Virtual.
They're gonna pull the wrong blade anyway, so.
Yeah, because that never happens, right? What's bad is when they pull the wrong disc. When you want them to.
Yeah, it's flashing
red.
Oh, damn it! Now we have 2 servers down.
Yeah, exactly. Yeah, that's always a problem.
Yep. No, it's funny. My first job out of the Air Force, it was right before we moved up here, or right after we moved into our new home in Wake Forest that we bought while we were down there. I became the person that lived closest to the data center, the primary data center. So it was always like, all right, if anybody's got a list of primary data center stuff, just write it on my whiteboard here outside my cubicle. I'll hit it on the way home,
Yeah, that's right. I'll stop by and then I'll just check them off one by one.
Yep.
So this one should go a little quicker because it's going to be the only one actually pulling that ISO. But whilst that is doing that, I can revert to this and I can show you some of the additional things we have in here. So we've been through, this shows you all about the information about the machine that is there. You'll also see that it's brought through a host name. Now, those host names match the names of the machines you would have seen in the iDRAC. Now, the only reason why that has happened is because my DHCP server allocates host names. So it provides that, through an option. But your DHCP server, when you're using this, doesn't have to provide host names. If your DHCP server isn't issuing host names, you'll simply have a random UUID displayed here. And to identify the machine, you can, of course, use lots of different things, perhaps serial numbers, BMC addresses, so you know exactly which machine is which. But you can then set a host name in here, edit host, and it's got the discovered host name, and you can override it. So if you want to, make sure that this has a known host name, something you obviously you want to use, you can set it here, and then all of the nodes inside of the cluster will be able to contact this machine through the host name you set here. No requirements.
Using the MDNS.
Using MDNS, but also Core DNS. So every machine has a Core DNS implementation on every machine. And so yeah. It follows the bare metal IPI path for all of that. So just waiting for this guy still. And yeah, there's a few additional things you can do in here as well. You can disable it, you can view host events, or you could delete it. So viewing host events, you can, this is it's not full right now, but when you are actually deploying and you're actually running through a deployment, this will be filled with really useful information about what is going on inside of that machine. So, for troubleshooting purposes, you can absolutely dive into this and see exactly, what's going on at what stage, deploying CoreOS onto the root disk, what the progress is on that. It's incredibly useful.
And someone asked, and I don't know if you're going to get to it when the third node is added. They asked early on, like, how do you tell the ISO whether something's a master, whether it's a bootstrap? But that I think that's something that you can actually do directly with the assisted installer, correct?
You can, and I'll absolutely talk about that. So the role, what we'll cover now. So here you can see role. It can either be automatic, master, or worker. Now, if you've only got 3 machines, you're by default, all 3 of them are going to be both workers and masters. But you could, I could be provisioning 6, 7, 8, however many nodes that I would like to, and I can address which ones are which. There's also some logic in here. You could leave them all on automatic, and then the assisted installer would, based on best fit, what resources do I have, or specification of the machines, which ones would make the best masters, which ones would make the best workers, and so it will automatically assign them. But it makes no difference here. I can just leave this on automatic because I only have 3 machines.
So what happens to anytime I do an install, right? There is an implicit even if you're doing a compact cluster, there's an implicit 4th node, right?
Yeah.
What role or where is the bootstrap, right? Is that in the platform itself? Is that in the installer?
No.
Where is the bootstrap in this?
What's actually really cool with this is that you don't need an additional node for the bootstrap process. It still has a bootstrap, and you'll absolutely see this shortly. But what happens is one of the nodes will get chosen to be the bootstrap machine temporarily. So what happens is, and we'll watch this happen in real time shortly, but the 2 nodes that aren't the bootstrap machine, they will get provisioned into CoreOS. CoreOS will get written, RHEL CoreOS will be written to the root disk. They'll be rebooted. The OpenShift cluster will start to come up on those 2 nodes in a temporary 2-node cluster configuration. It will start etcd, bring up the OpenShift control plane. And once that has happened, that 3rd node that was the temporary bootstrap will then pivot, redeploy into CoreOS, and become that 3rd cluster node. So that bootstrap is just running temporarily like it would normally. But the real beauty of this is that it doesn't need that additional node to do it. It just runs on one of the main nodes temporarily.
That's awesome.
That
is so cool.
So that was actually early on. I asked, I'm like, hey, can we like make the bootstrap like a container? Can I run it like on my laptop? It'd be cool, like I just do a Podman run. But I think this is a lot cooler implementation, especially if you're like low on resources, or if you're doing like a bare metal install, or if you like really only have 3 nodes, it'll pivot that one of the masters.
Exactly.
The bootstraps into a master. So that's really cool.
Exactly. And you think about some of the configurations that customers and partners are looking to do, minimal footprint right at the edge. You don't want to have that 4th node there, or you don't, if you can help it, right? Just having 3 nodes, that's incredibly useful. All right, how's this getting on? All right, that's finally up and running. So we should see that additional node coming in here in just a couple of minutes. And then we should be able to proceed with the rest of the installation. You'll see it starting some additional containers, and it's going to do a little bit of discovery of the configuration of the machine. Here you can see the classic mount invalid.
Yeah, it's like, hey, I'm like, hey, there's an error, and then they told me, don't worry about that error. I'm like, okay. It was never explained to me what it was, but okay. It was told to ignore it.
Yeah. All right. We now have our 3 masters, or our 3 nodes reporting into the assisted installer UI. Now, again, I'm just going to leave this role automatic. I could force it to be a master. I couldn't force it to be workers, because that would mean there were no masters and the install would definitely fail. So I'm just going to leave this on automatic for now. But as I said, there's logic built into the assisted installer UI to try and do that best fit placement of the roles, should I have more than 3 nodes. Okay, so now we can move on, assuming there's no additional questions on what I've shown so far. Now we have to provide the base domain. Now, again, just like any install config, you have to provide a cluster name and a base domain. Cluster name we've already defined as PemLab, because I want it to somewhat match the DNS environment that it's going to be going into. So for me, this is just rdu2.redhat.com. So it's just an internal co-location that we have. So we go the full cluster address, pemlab.rdu2.redhat.com. Now then, it's going to ask me some additional questions. What does my network configuration look like? Now, basic is very, very simple. We use the out-of-the-box subnet allocations. So, the cluster IPs that would be used, and the various other subnets that we use inside of an OpenShift cluster, for the SDN type networking and the pod networks, I can override those, or I can leave them as they are by selecting advanced, and you can sort of select things here, service network, cluster network, and various different things. But I'll just leave it with defaults and just go with the basic allocations. We select which subnet we want to use. Now, I only have one network configured inside of this environment, but if you had multiple, you could say, well, I want to use this network to do all of the, this is where I want to put all of my APIs and the ingress going on. So I'm just going to select this default network. It'll verify that all of those are available on all 3 nodes. Now, this is important because, as I said earlier, the cluster is responsible for doing all of the load balancing, all of the IP, the keeping those VIPs up and running, and managing internal DNS. So it has to make sure that the network that you select for where those IPs listen is common across all 3 of your masters. Now then, the last one question is around what are the IP addresses I want to use for the API and the ingress. Now, again, if you want to use known IP addresses, for example, you've already communicated with IT and you've said, well, I need DNS entries for API and ingress, and I just need to know what IP addresses you've set up for those. You can plumb them in here, and the cluster will bring those IP addresses up, and it will just receive requests, and you can rely on your external DNS to point all of the traffic to those IPs that we put in here.
Nice.
But what's really cool, one of the newest features of this, is I can allocate these virtual IPs by my DHCP server. So if you're unsure of what IPs you want to use, and remember that I just want to put this into an environment where I have very minimal external requirements, and I'm going to update my Etsy host to point at this environment when I'm done, this is really cool. So if you don't know what IPs you can use, well, just hit allocate virtual IPs via the DHCP server, and it will find IPs that you can use. Now, inside of my environment, my DHCP server will happily allocate IPs to any device that wants an IP, right? That may not be the same for all of our customers. I completely get that. But in environments that will, this is handy. But of course, it has the option where you can fix them should you want to. What I'm going to do at this stage, I'm going to say validate and save changes because I wanted to try and grab IPs. You'll see that you have this spinning wheel here where it'll try and grab some IPs from my DHCP server in the lab. It should only take a couple of seconds to find IPs if my DHCP server is being friendly.
If someone, and I guess you alluded to the answer is no, but if someone does have a DHCP server, but they do like MAC address filtering, is there any way to have them to automatically assign it, or do they have to go the static route at that point?
I believe they'd have to go down the static route first, because I think that the MAC addresses that we use here are randomly generated.
Gotcha.
So we wouldn't know, although I'm sure we could find out from some of the engineers. I don't think that we know what they are up front. But they are, if I recall, just sort of they just use the libvirt type MAC address range.
The range of, okay.
Yeah. So yeah, now we've got these IPs, so 10.11.173.189 for the API and 187 for the ingress traffic, allocated by the DHCP server, but it's the cluster's responsibility to keep renewing this lease. And again, those IPs will simply listen using keep alive D.
Right.
Last question, do I want to use the same host discovery SSH key? So the same SSH key for the resulting cluster? Yeah, I absolutely do. What you'll then see is the cluster is ready to be installed, and you'll also see that these 3 have turned to known. So these machines are ready to go. So I'll go ahead and click install cluster. And what you'll see is that in a second, one of these will turn to be the bootstrap machine. You'll see it come up there in brackets, bootstrap.
Nice.
And take a couple of seconds, and you'll see it, list a few different things about the environment that have been coded for me, because I selected the default, so standard cluster network, standard service network, and so on. And whilst it's doing that, you'll see that nothing is happening on these machines just yet, because the back-end environment is still working on setting all of this up for me. So there we go. That third node, node 11, is our bootstrap machine. And you see it's starting to progress 14%. We can go in and view cluster events, and this is fantastic. This will show you all the information about what's going on as and when you want it. So you can see, node 11 is writing image to disk, so that's actually writing down the CoreOS image directly to the root disk. And if I was to go on to the environment here, node 11, you'll see in a few seconds it'll you'll see this machine essentially rebooting, so it's no longer reliant on that discovery ISO. It'll just be running off its root disk. And again, it takes a little while for it to do it, but this information here is really really useful to have.
I'm about to type one of my idiisms in, or is it an idiom? I don't know what it's called, but like, technology exists to improve human existence. This is the evolution here, folks.
Yeah. Chris-isms, right?
Yeah, Chris-ism. There you go.
Short-isms. I don't know which.
I don't know which. Short-isms, shortitis, whatever. Yeah.
Yeah. Evolution at scale.
That's right. So, I mean, there's not really too much to see what's going on. Node 11, that's our temporary bootstrap machine. So you can see this. You're going to see this one. Keep provisioning additional container images. They're going to come up because that's this is the one that's going to help orchestrate the deployment of the OpenShift cluster, the temporary 2-node OpenShift cluster on this node 10 and node 12. So we're going to see these two reboot first into their disk. There you go. This guy's off. This guy's going.
Someone mentioned the fonts are small. Yeah. So in the beginning, if you didn't catch that, this is a remote desktop into another system, so it's kind of hard to scale.
It's multi-layers of remote desktop.
Yeah. So Reese is remote desktoping, and then from there, remote desktoping into somewhere else. So it's.
Yeah, sorry,
it's
folks.
Not fun.
What's written here is not really too important. I'm essentially just saying that these machines will have their root disk provisioned first by the assisted installer, and they will come up as the 2-node cluster. So I just wanted you to see that these two machines will reboot first. So you can see node 10 is currently in its BIOS. Node 12 has just been rebooted. So those two will come up with the OpenShift cluster first, a temporary 2-node cluster. Again, 2-node clusters are not supported, but it's only temporary because we're using this third node, or in our case, node 11. As you can see here, node 11 is the bootstrap machine. And then once the OpenShift installation is complete on the 2, node 10 and node 12, it will then pivot and become that third cluster node.
So just a bit of a technical question. When this node, when it's a temporary bootstrap, is that running off the ISO? Or
yes.
Okay. And then the last part of it is to actually write the master configuration to the disk, and then it'll reboot. So it doesn't.
Yep.
It doesn't reboot as bootstrap, and then it does some magic for it to reboot as master. It's all running off the live ISO.
Yeah, exactly. And you'll see that this one hasn't rebooted. It's only the node 10 and 12. I'm sorry for jumping back and forth. 10 and 12 were our masters, and node 11 was the bootstrap machine. You'll see this node 11, it won't reboot until much later on in the process. So you can see there's as well some additional steps, so it'll show exactly where it is. So node 10, it knows it's in the rebooting step, which is step 4 of 7. Node 12 will also be rebooting. Node 11, which is our bootstrap, you see waiting for control plane. So it wants to make sure that the OpenShift control plane has been established on those two nodes before it will actually proceed any further. And again, all of the cluster events, they will continue to spout out information about exactly what's going on, all the various different stages. Node 12, which was one of the last masters, provisioned its root disk. Now it's rebooting, and now it's reached the configuring stage. So you'll see if I go back, you see this node 12 is now in the 5th stage, which is configuring. So it's actually bringing up that OpenShift control plane on that machine. So whilst we're waiting for some of those things, you can abort installations at this stage. If things go wrong, there are options for retrying an installation. It's actually really powerful. There's also the ability to download installation logs. So we'll be downloading it halfway through, so it's not really a good indication of what's going on. And in fact, you've only got 2 of the machines, which will be our 2 masters so far. You can go in here and you can gather additional information. So installer logs and agent.logs.
That's cool. Yeah.
So you can see exactly what's going on. Again,
yeah, just in case you really love small font.
Yeah, sorry about that. So
no,
this is. I can probably open this in. I thought I could change it in here.
It's probably on the text editor menu on the top left, right? Is there a? Oh no, that's right there.
And colors.
You found it.
Use system font size.
Yeah, make it like 32 or something ridiculous. Yeah.
Yeah, so this is just output out of one of my master machines. So you'll see, for example, it's all about talking about the root disks, writing out the CoreOS metal image, downloading it from the essentially OpenShift CI, writing that out to the file system, and then essentially rebooting that machine. So we download these logs a little bit early in the process. But you can continue to download these files and get more insight into what's going on. Or if, for example, the install failed, you can exactly see what the OpenShift installer has tried to do. Where did that fail? Is it timing out because you can't get access to a HTTP proxy, or does it not have DNS? It can't retrieve or can't access the container registries because of perhaps a DNS problem or something like that? Or did it just time out? There's lots of different reasons as to why this can fail, and having access to those install logs is incredibly useful, especially being able to download it directly from this UI.
Yeah. Well, even though we've endeavored to try to make things as automated and as self-contained as possible, it'll still inevitably fail somewhere, right? Because we can't account for every environmental issue. One of the issues that people actually run into as even as someone that I wrote the helper node, right?
Mm-hmm.
So a lot of people know about that. I actually get a lot of GitHub issues, and it turns out, and actually Chris, who had to step away for a second, actually had a similar issue where the disks were just too slow, right? So etcd
back.
Yeah. Now he's back, right? Speak of the devil and he shall appear.
Yeah.
And so there's a lot of environmental issues outside that essentially our control, right? And one of which is make sure your disks are fast enough to run etcd. There's actually a script you can run to make sure
it's super quick and easy script too. I'll drop the link to it because I actually bookmarked it.
Chris actually had the issue. I had to help him debug something with the
while you were moving, it was like, dude, what is going on with my I had the 3 master nodes were just like one would reboot every once in a while, and I was like, I have never seen this before. What could possibly be going on? And he was like, what kind of disk are these? And I'm like, they're HDD 10K disks. And he's like, how many do you have? I'm like, 4. I'm like, 4. And he's like, that might not be fast enough to run this thing. And yeah, sure, no, it was definitely not fast enough to run etcd, let alone the rest of OpenShift or Kubernetes in general, right? So if you can't run etcd, you're not going to be able to run anything else. So yeah, it now has shiny new SSDs in it.
Fantastic.
So first of all, it's good to be here, and apologies for being here late.
I hear you, but I don't see you.
I hear you, but I can't see you. Yeah, I hear your voice is the voice of God.
I see him. I see him. I see him in the Twitch.
Oh, you see
Why don't y'all see him? Oh, do you have him in gallery view?
But I don't see him in the gallery view. No.
Yeah,
no.
You got to change yourself to gallery view.
Gotcha. Yeah, no, I see him.
Yeah, I don't know how to do that, so I'm not gonna do that.
So, no, well, I had a previous commitment that somehow I missed on my calendar. So not that I had any worry that you all actually needed me for any reason. But
I need you.
You know, that's not for the stream. Yeah.
That went wrong quickly.
Yeah, that went south quick.
So I did want to comment on the etcd performance thing. I don't know if you all noticed, I sent a long diatribe to our internal OpenShift SME mailing list around that the other day of, etcd and the way that it functions is extremely latency sensitive, and not just for disks, but also for the network. And the lower that latency is, the better an experience you'll have. And the higher it goes, the worse things get. Like you really want to get that. I think our unofficial recommendations are 10 milliseconds of disk latency, and I think 5 milliseconds of network latency. And
which I have now way more than that. I have way more less latency and way more speed than what I need now, which is just. And now that assisted installer is here, like I'm kicking the tires on it right now. I just downloaded the ISO.
Yeah, assisted installer is it's nice. I'm excited about it. I'm excited to see it in action and see it really getting the tires kicked, so to speak.
Someone asked, is the etcd benchmark part of the assisted installer? Would it warn us? Would it warn us if our systems were shoddy?
That is a very good question.
That's a good question. If it isn't, it should. That'd be,
it's
really good.
that's a very simple command to run in there, folks. Like, it's not that hard.
Yeah. So essentially, when the ISO boots up, there's, in theory, when we are doing the discovery, there's no reason why we couldn't actually run a disk benchmark or something like that, just to check and put a warning here. I mean, that sounds like a great RFE. So I could see, I could go into my node and say, okay, this machine,
it has like a little badge or something.
Yeah,
that says,
exactly. Disks are good to go, at least at this stage,
Right.
And if they're not, you could still force it through, and your mileage may vary, but
someone says faster disks for masters. And also, I'd like to reiterate what Andrew said, also network latency, right? Because the algorithm that has to run over the network. So
yeah, the way it commits data is it traverses the network, I think 3 times to do the etcd
very chatty
store. So effectively the data is received by the lead node. The lead node then sends it to the follower nodes. The follower nodes then act back. So now everybody has the data. Then the lead node then says, okay, now everybody commit the data. And at that point, it is actually stored. So
which is why
network traversal in there.
Which is why a stretch cluster won't work, right? For masters, at least, right? If you have a master in LA and one in the UK, that's just that's just not gonna.
Or why it's highly complex, right?
Why it's highly complex. That's definitely true.
So the way I've seen people do quote multi-cloud, and there's a lot of talk about multi-cloud and how it's bad right now. But the way I've seen people do multi-cloud is they actually have OpenShift instances in 2 different clouds, and there's work that, independent workloads that happen in each cloud kind of thing, right? But those independent workloads could, in theory, be the same, and you can use BGP, Anycast, and make it look like you have 2 different data centers at the same time kind of thing. So that's entirely possible, right? Like multi-cloud doing it that way is the multi-cloud that I think of, right? Not necessarily like I'm using multiple clouds at the same time just because I can, kind of thing, right?
Yeah.
Like,
well, yeah, in not to go too far off topic, right? Is in the end, multi-cloud is really dependent on the application, right? The people are trying to solve it with infrastructure, and you can, right? It's all in the app, right? So if your app can't run in multiple clouds, then it doesn't matter how you set up your underlying infrastructure. So
right.
Yeah, agreed.
Exactly.
All right, sorry to interject. So both of my master nodes are now installed.
Nice.
Right, so that's, those two are good to go. This one is still waiting for everything to now properly come up on those two machines, and then it'll go ahead and it'll proceed, and it'll then pivot and become that third master node. You see, waiting for control plane. This is installed, so this has completed its installation successfully. Okay, now whilst that third machine actually then goes ahead, and we might actually see this rebooting it. No, it's not. So I want to show you download kubeconfig. So directly right from the UI, we can say I want to download the kubeconfig, and I will bring this up, and you can see that there. Now I can't contact this yet, primarily because I haven't set my DNS to point at this environment. I could go in and I could edit the DNS records inside of my lab, the corporate DNS records, to point to the IPs that it allocated me inside of this cluster. But I'm going to wait until the OpenShift cluster is fully up and running to do that. But it's very convenient to be able to use this or grab this kubeconfig directly from the UI.
Nice.
And what I will do is, whilst we're waiting for that third machine to come online, I will do export kubeconfig. No, what was it called? What did I download that file as? No. What did I download that file as? Let me download that. I don't want to show in a folder. No ingress. I remember, sorry. Let me.
that's a heavy-handed.
Yeah.
Remove all my kube configs.
Yeah, it's okay. It's just from doing lots of these.
So Reese or Christian, Reese, you're typing, so I'll poke at Christian.
Okay.
There's a question from C Santana. How does system file partition configuration work? For example, infrastructure nodes that need some special disk setup for logs or registry images.
That would be a post step, right? Like you would have
well,
to.
Yeah, there is the partitioning happens, I know, automatically. I don't know how that layout looks like. I would have to just like dig in and just kind of just see what that layout looks like. I know you can, as Chris alluded to, as a day 2 step, add additional disks. Where those where the containers live, I don't think it's configurable at this point. Yeah, someone mentioned by default we install the everything on the first disk, right? So if you have like 12 disks, we install everything on that first disk, which is why I think we require minimum 120 gig.
Right.
Yeah. Yeah. So by very much to that point, right? By default, we don't configure it at all. It assumes that the entire installation disk, which can be controlled when you install CoreOS, right? You can specify, I think it's inst disk or something like that, as SDA, SDB, whatever you want to use for that. But it will assume that it can occupy the entire disk, and there is no partitioning. There is no, right? We used to recommend things like graph storage being, for the Docker daemon being on its own partition or its own disk, etc. The official recommendation is none of that is a recommendation anymore. So and implementing that at install time can be done, but it's not straightforward. And Reese, I
Wow.
don't know if any of that is incorporated into the assisted installer or not. I don't think it is.
No, not at this stage.
But yeah, effectively our generic recommendation is one disk for everything, and then clean it up afterwards if needed, which we don't think will be needed for many or most instances.
All right, so
like of all the things for Twitch not to pick up on.
Yeah, sorry.
Right, like so we have a running joke. The mod actions panel in Twitch is literally like yesterday it blocked Christian Posta, his name, right? It's just like, and I accidentally type in the wrong thing as, you know, S and C are close on the keyboard, and there we go. Yeah. Thanks, Twitch. My bad.
Yes, nice.
Sorry, everybody. That was not my intention. And of course, there's no edit button or I guess I could delete it.
I guess, yeah, that's right. or leave it in all its glory. We don't know as a
I don't know.
as a warning to others.
Yes. Yeah, block Christian Posta. Don't know why. I think it was you, Narindev, that mentioned it. It like put your thing on pause, and I was like, wait, why? What? It doesn't tell you why. It just says automod. That's it. It's just okay. Is it the word Christian? I don't know.
Actually
is it some multi-language thing, or
I sent that screenshot to Posta, and he laughed.
Yeah, Narindev was the one that mentioned it. It was just like, what? And of course, today it's like, oh no, you can go ahead, Chris. It's probably because I'm like a moderator or whatever.
Yeah, you're probably because you're a mod.
You should always mod the mods.
All right, folks. So where we are now is this third machine, our Node 11, which was our Bootstrap machine. This is now since rebooted, and it's, you know, this machine has a bunch of nicks on it, so it's just going to go through and try and DHCP on them all just by default. It's eventually going to give up, which it just has, and we'll see this machine then bring up all the necessary control plane services, you know, etcd, all of various different Kubernetes bits and pieces to be that full third master node. And you'll see that now we're at 95% complete. This is in the configuring stage, which we previously saw on the two masters. And hopefully in just a few minutes, this will go to 100% complete. And it's going to give us some additional options just at the top where we can go ahead and actually connect into our new bare metal cluster that have been deployed with the assisted installer. So
nice.
Just a few more minutes and we should be good to go.
Yeah, I saw also, Reese, just in case you care, I figured out how to bring Andrew up on my view.
Oh, you did?
Yeah, there's like a little triangle next to...
Oh, yeah.
If you click that triangle,
it is.
It makes Andrew appear. The triangle makes Andrew appear.
Oh, because he scrolled off the screen? Are your windows small and he like scrolled down?
Yeah, it basically,
yeah. Sorry.
I was like,
no,
I have
you all
Andrew,
open on like a 4K screen right now, so.
All right. Oh, so it looks like it came up as a master.
Mm-hmm. Yeah, this one is up, and it's just going to take a few more minutes to get exactly where we need to be. What I can probably show is the latest installation logs, and let's see, 31 kilobytes. That's going to be our Bootstrap machine. And you can see you got the boot cube logs, the agent logs, which is, the agent is for the is the logs. So the agent is a service that we bring up on each node when it boots up as part of the assisted installer, and so this will show us or give us logs for pretty much everything that's trying to do. You know, connect out to the cloud@reddit.com, get everything set up. Bootkube, well, we all know what Bootkube is. That's a service that establishes or helps us bring up that cluster in the first place. And then we have the installer logs, and so this is the OpenShift installer logs, and we can see, you know, everything that's going on. This is a pretty long file. You can, you know, not going to go through all the text in here, but this is obviously really helpful to troubleshoot anything that goes on. But there's plenty of information that's available just at the click of a button from the UI.
Always handy.
Mm-hmm.
Yeah, because usually you have to SSH into the Bootstrap and then run the journal command and then pipe grep and.
Yeah, I mean we still can, right? You know, we can.
Yeah.
I can do And assuming there's no issues with my key or things. So, this is one of our machines I can, directly connect into.
Mm-hmm.
So you can see these are all the pods that are running. I mean, this is a machine that I have provisioned. This is one of the ones that is installed by this. So, I have direct connectivity, and obviously it took my key because it didn't ask me for a password, and so that got injected during the provisioning of this. So, you still can go in there if you want to. You can view the logs. You can watch Bootkube running if the Bootstrap machine was still up and running, but we're kind of past that at this stage.
Yeah, someone mentioned, and it was already answered, but someone had mentioned that this is RHEL Core OS only, right? It's not RHEL 7.
Correct.
Yeah, it's RCOS all the way across. Yeah.
By the way, RHEL 7, 7.9, right?
7.9 was released,
which is the last release of RHEL 7, which seems weird.
It feels very odd.
It feels weird because I remember using RHEL 3, RHEL 4, or whatever.
RHEL 5, yeah.
Yeah. I remember that being the thing. And then now
I remember the big sea change that 7 was, and now 8. 7's retiring, and it's
yeah. Well, you saw 4 years, but I mean, it's in the last phase of its update cycle,
right. It's the last official release kind of thing. Yeah.
I remember being an SA and going around to my customers when RHEL 6 came out, and positioning RHEL 6 and all the new features, the latest and greatest. Some good times. I found a lot of the old presentations I used
for RHEL 6.
Yeah. It's kind of funny. I should be almost there, folks.
I guess it means I need to upgrade from RHEL 6. Most of my servers are on either Fedora. I'm either on either end, right? They're either on RHEL 6 or on Fedora 33, 32, whatever the latest one is.
32 is the latest. Yeah. 33 is beta right now.
Yeah, I was going to say I saw an email about 33 being on beta.
I think it releases in mid to late October.
Yep.
Yeah, it's October releases usually, right? October and I forget, April or something like that. Or they're going to yearly now. I'm not sure.
Fedora is?
I think. Or the
20.1, 20.12.
Yeah.
Naming convention or versioning standard or whatever.
I think, yeah. Who knows?
So
someone would know that.
I have a question for you that came up the other day in one of the chat rooms, which was support for static IPs with the assisted installer.
Not yet, because we rely on DHCP as part of the process. So the only way you're going to get a fixed IP is if you're statically assigning it because you know the MAC address or you know the machines that are going to be requesting an IP. You can, of course, have static IPs for API and ingress. In the previous pane, we showed where you could force those.
Yeah.
But the IPs that we grab as part of this, well, the IPs that are used for the nodes, we rely on DHCP for those.
And you might have already covered this, right? My fault for being late. Does this leverage an external load balancer, or
no? It's self-managed. So it follows model. Exactly. It's exactly the IPI bare metal model here.
Okay.
All right. So
that already, by the way.
Yes, I believe we did. Yeah.
Oh,
all right. So
it's up.
Installation has now finished. We're kind of good to go. We're going to have a problem here because, again, I randomly allocated my API and my ingress IPs, so they're not going to have a corresponding record. So if I click on this, it's simply not going to work. But what's really cool is if I say, well, I'm not able to access the web console, it's going to give me all of the entries that I can throw directly into Etsy hosts. So I will just go ahead and I will disconnect out of that guy. And yes, I'm using Nano.
That guy.
And I
don't care you're using Nano.
So there's a reason why I use Nano. When I was in my teens, I guess, I got really into Gentoo. Gentoo Linux.
And
all of the documentation for Gentoo uses Nano. And so I just started to use it. And I know every single person I've ever ran into completely slates me for using Nano, but it's just what you're used to.
No.
You're used to all the keyboard shortcuts for doing everything. So I'm just going to stick with it, I think. All right.
I think you should.
So all I've done there is I've pasted those in there. So you can see 187, which is the ingress. And I've got some, fixed entries in there and the API on 189, which corresponds to the IP addresses that got allocated by my DHCP server. So I can save that now, and right away I should be able to do OC get hosts at nodes. Come on, Reese. And those 3 machines are there, and you see they are all both master and worker. And you'll see we have a discrepancy here between, these 2 machines have been online for 16 and 19 minutes respectively, and the third one is only 2 minutes 44 because that was that third temporary bootstrap machine.
Oh, nice.
OC version, 4.6 nightly. As expected, my client is 4.5, but that's irrelevant. So now what I should be able to do, I should be able to launch the OpenShift console. Connection is not private, to be expected. It's going to do that for a second time as it goes to the OAuth, but this is a good sign. And let me make that a little bit bigger, get rid of that and that. So by default, it's kubeadmin, and the password I can grab directly from here. I can copy it there, and I'll paste that, and away I go. So you can see we're up and running. OpenShift 4.6, provider is bare metal. So again, because it's following the bare metal API path, it has already deployed all of the pieces, so it's got the keep alive D, it's got the core DNS, the MDNS, everything all ready to go up and running for me. You'll see that some of these machines, some of the pods and stuff are still coming up and running. It's got the bare metal host entry, so I can dive straight into this. Now, the important thing to note here is that it does deploy all of the metal cubed pieces for full bare metal management, but metal cubed is currently disabled in this release. The main reason for that is that when we use the metal cubed configuration, today it relies on a second dedicated provisioning network.
Right.
Now, assisted installer, we try and make it very, very simple and easy to use and only require a single network. So until we catch up, I think around about the 4.7 timeframe is when we're going to drop the requirement for that second provisioning network, where we will be able to enable metal cube right out of the box. So what I'll be able to do in here is go and edit this bare metal configuration, set the BMC or the out-of-band management configurations, and OpenShift will be able to manage the control plane, manage the underlying infrastructure, just as it would with like it does on a full bare metal IPI configuration.
Beautiful. That's amazing.
But yeah, we're there. And
we're there.
Yeah,
we have arrived.
We've arrived. Yeah. Well, even with that small hiccup, right? The small ISO hiccup, we did it in less than 90 minutes, right?
Yeah,
like about 80 minutes.
Yeah, like that's very impressive.
Install started 15:55, installed 16:24. So the installation, 30 minutes.
Wow. Dang. That's impressive.
That's
I'm very happy with that, right? Like having stood up enough Kubernetes clusters to know that like that is like almost as good as like our, partner demo system, right? Or faster even, right? The fact that you can get a node or a cluster in 30 minutes. Wow. That's just amazing.
Yeah, someone mentioned in the comments, this is actually pretty cool. Now all you need is to have an operator to update the firmware of BMC on these nodes. That would actually be pretty cool.
That would be amazing.
That would be really cool.
I actually think that the Metal Cube stuff is looking into things like that.
Like the firmware update manager?
Yeah, because Metal Cube uses OpenStack Ironic. And OpenStack Ironic does have some capabilities to do, out of band configurations. I don't know whether progress was ever made on the firmware updating, but in theory, there's no reason why that interface couldn't be used at some point to do that kind of stuff.
Yeah, that's awesome.
Yeah, and this is a bare metal environment, so we can do, we could deploy OpenShift virtualization if we wanted to, right?
Right.
Yeah,
Now
you
you're
don't have
just
to worry
showing
about
off.
nested vert.
Now
right?
you're just
Like-
No
Well, no
nested
need for
vert.
nested. Yeah, no need for nested vert, right? Because you're running on bare metal.
Yep.
Exactly. You can do all the fun things.
Oh yeah.
That's awesome.
And as
So
we
you
know,
can technically
super simple.
install OpenShift on OpenShift, right? Using
Vert.
OpenShift Vert, right? Because they're just virtual machines.
Sort of.
Well, I mean, if you use the agnostic installer,
So let's talk about that.
Oh, God.
Yes,
Do it.
technically, you can deploy OpenShift to OpenShift virtualization virtual machines. So why am I talking about it the way that I'm talking about it?
You seem like not a fan.
Well, because we need to clearly understand the expectations, right? Am I creating child clusters where the parent physical cluster is, for example, I'm creating routes there that route to applications in the child clusters? Excuse me, sorry for bumping the microphone. Or am I creating virtual machines, OpenShift instances that are connected directly to an external network, just like a traditional one? So it's not as straightforward as just, deploy OpenShift right into OpenShift. It's what is my expectation around how it's deployed, how it's configured, and importantly, how the applications inside are deployed and connected to. And that's why there's some hesitation or some, it's not quite as straightforward as you would think it is.
It's level expectation, right? So
yeah. So, but yes, there is nothing that technically prevents you from, especially if you have configured a direct L2, layer 2 network connection for those virtual machines.
Right.
Sure, deploy it into a virtual machine, connect it out just like you would with a traditional hypervisor, not a Kubernetes-based hypervisor, and connect to a standard OpenShift cluster. But if you expect any kind of integration between parent and child, that's the complex part or the missing part.
Yeah, there's the way Andrew answered this is indicative of the questions we get asked, because sometimes we'll get asked questions and we go, yeah, that's like technically possible. And then people take it as like, oh, I can do it and expect the same performance, or I can do it and it's
supported.
Like, it's supported. Yeah. It's like, no. Like we're just talking, sometimes you have to like differentiate.
Yeah.
Like, okay, like you can do that, but or we recommend doing this. Or as long as you keep this in mind, you can do it. So like we've Andrew talks like someone who's been burned on that a few times, just like I have.
Well, it's funny, right? Because there is, Chris, you were in the military, right? There's kind of two different types of people that you'll encounter sometimes, right? Those who, if it's not explicitly permitted, it's denied. And those who, if it's not explicitly denied, it's permitted. So sometimes you have to be careful of, that what Christian was saying around what's technically possible but not supported, and
right.
Also setting expectations.
Yeah, highly important.
Oh, look at that! As we were talking, the operator installed OpenShift virtualization.
Ta-da! Operators are grand, aren't they?
Look at that! He's creating a VM.
I might have a bit too quickly, but
like Andrew said, he's just showing off. This is cool, right? Like I'm spinning up VMs like on my local instance and I'm seeing them appear on cloud.redhat.com. Like this is really awesome stuff, right? Like this is slick. Yeah. I really like this.
And you can view all of the clusters that you've deployed in here. So, again, you could have lots of different clusters in different places. And I've deployed this on bare metal, but there's no reason why you couldn't follow the same path if you're deploying on top of, your virtualization cluster. It doesn't really matter. Just attach the ISO, away you go. You can view all of the information here. You can delete the cluster if you want. Just deleting it here just deletes it from the assisted installer window. It doesn't actually decommission the actual cluster itself, but you can imagine you've got a list in here. You can go into them and you can launch the OpenShift console directly from here. You got everything you need. Your kubeconfig, passwords, it's all stored by the assisted installer configuration. So it's incredibly convenient.
Someone asked, and this is way off topic, but
I
want to make sure we get to
the admin hours.
It's the admin hour. I want to make sure we get to some of these questions. It says, what's the estimate date for 4.7 release? Right. So I think
4.6 is coming.
4.6 is coming. I think it's 9 months. I think we've been doing a release cycle. I'm not sure, 6 to 9 months after.
It's every 3 months.
It's
every
quarterly
3 months.
releases for Kate's. So,
well, it's because I'm thinking about the EUS release of 4.6. Has that changed? Did that change anything?
That won't change the release cycle. That changes the support cycle.
The support cycle, yeah.
So
there you go.
So 4.5 was July.
July.
So expect 4.6 roughly 3 months later, right? So again, subject to all kinds of things, and then expect
disclaimer from Serena from the Future Show,
So and then expect 4.7 roughly 3 months after that.
Yep. I mean, we try to follow the cadence of the Kate's upstream, right? That's the biggest
like
thing.
one behind or whatever.
Yeah, usually.
Sometimes 4.5 was 4.5 is
parity?
Kubernetes 1.18, so it was same as upstream.
Yeah. When it was released, it was, yes. Now 1.19's out, so yeah.
I see you sitting at that VM console, Reese.
Quietly, I just wanted to prove that it.
Go ahead, Reese.
that it worked. I deployed a VM on top of my bare metal OpenShift cluster.
So there you go, 30 or 29 minutes to go from bare metal to OpenShift, and then another 4 minutes to go from OpenShift to
VMs. Yeah. Wow. That's so amazing. This installer is going to change my life, I feel like.
Yeah, it's really convenient.
Yeah. This is awesome. All right. Well, Andrew, it's your show. What do you want to do now?
So Reese, are you at liberty to discuss anything roadmap related or?
No, I would say not at this stage. We've just made this available. What I've just done, anyone can do. Just because just because I have an employee account doesn't mean that you shouldn't see that same direction. Or you shouldn't see that same option inside of your cloud.redhat.com interface. But this is the first time that we've made this available. It's obviously been a work in progress. We've been working on this for a number of months. I've been doing some internal demos to show it, and the rate at which this has improved, new features and RFEs that have been brought from folks in my team and lots of different areas. They've been implemented, and it's really, really strong. It has a strong roadmap. We talked about the possibility of having this available inside of your own data center. That's something that we're really looking at as well.
That Pixie boot aspect.
Yeah, there could be things like that, but at this stage, no, I'm not really at liberty to discuss the roadmap for it.
That's fair.
That's fair.
I will say that I saw the first video that you created of this, and saying that there has been tremendous change and improvements and expansion of capabilities is a bit of an understatement. The team, and I don't know the team that's behind this very well. I know their product managers a little bit because I used to work with them on the virtualization side, but they're doing some incredible work. Not that the rest of OpenShift isn't, but really, really impressive. So there's a question in the chat, and I think that it will probably be a somewhat subjective answer, but I'll throw you under the bus first, Christian. In general, for a fixed amount of resources, would you recommend fewer large virtual machines or more smaller virtual machines? So the context here, I think, is I've done a sizing exercise. I've determined that I need X CPU and Y RAM. Should I break that up into, fewer larger nodes or more smaller nodes in order to accommodate my application workload?
Yeah, so the first thing that you need to keep in mind is that there is a ceiling in terms of how many pods per node Kubernetes and by extension OpenShift supports. So it depends how dense you think your workload's going to be, right? If you're going to run containers that are 5 gigs each, then I mean, you won't hit the ceiling.
How many people do you honestly think are porting over 5
well
VMs,
that's
right?
The first step. Let's just put everything in one giant container, which I wouldn't recommend, but people do that.
We can't change that.
We can't change that. I'm a fan of actually of leveraging Kubernetes and OpenShift, just how it was designed. It was designed to scale out and not necessarily to scale up. I've always been a fan of having lots of number of smaller VMs, right? And letting Kubernetes do the scheduling, do what it does best in scheduling those workloads, right? But again, going back to it all depends on like your workload, right? So which ceiling are you going to hit, right? Are you going to hit capacity ceiling first, or are you going to hit the total amount of supportable containers? And that's also networking, right? Because there's just a finite number of
ports,
IP addresses that you
IPs,
ports, IP addresses. So you have to take some of those into considerations as well. But I'm a fan of the many smaller ones.
Yeah. I'll add a couple of additional considerations. So one, it's not just CPU and RAM, and on the node and of the pods themselves, it's also storage, right? So you mentioned the size of the images, but also how much of that local storage they're using. Yeah. So for example, if you instantiate a container image and it's writing gigabytes of log data, every minute, that's a lot of local storage. And that local storage needs to be sized appropriately, both gigabytes and IOPS and latency for that workload. And that could affect how dense your pods can be, which then therefore affects the size of those nodes and the quantity that you will need. Same thing with network. Right? If I'm running, I'll pick on CNFs, right? Containerized network functions. If I've got a CNF that's consuming an SRIOV or DPDK device and eating tens of gigabytes or gigabits of throughput, I might not be able to, put those very densely. Even just a database node, right, or a database pod. If my database pod has massive amounts of traffic, or a web server pod, or Redis pod, or whatever it may be, that's something to take into account, which is the amount of traffic that is capable of supporting. And I think even with virtual deployments, that's important, because your virtualization deployments are consolidating those nodes as well, right? I may have 30 nodes in OpenShift, but if they're on 4 physical nodes in my hypervisor, right, still have to be aware of those things. And the last thing before I talked over you, Chris, so I'll hand it back to you. But the last thing is failure domain, right? Yeah. Your application and understanding the application architecture and how it handles failure is important. So if your application is, built assuming that it's going to fan out horizontally and have, 40 instances to be able to tolerate, node failure or something like that, and then you've only got 3 nodes where suddenly it loses 33% of its capacity because one node failed, that's something to take into account. So be aware of your application, or at least make sure the application is aware of your infrastructure architecture so that they can make decisions as well.
It always comes back to, you have to know your application stack. You have to know what's going on inside your data center. And, we can expose all those metrics you want, but if you don't understand that the message queue in your work center is like, the most important thing and most IO intensive, network intensive thing in your entire stack, like, you've got to treat that accordingly. If you don't know that, you're going to hit a bump in the road real quick, right? Like, got to know your infrastructure.
Yeah. And I think it goes both ways, right? Of the infrastructure team or the platform team needs to understand the application, and vice versa. I used to give a talk about, strangely enough, it was vulnerability in IT. Right. And Brené Brown, who gives a phenomenal TED talk about vulnerability in relationships. Right. And of course, it's often in the context of spouses, right, or long-term partners, et cetera. But the same thing applies oftentimes in work relationships, and in particular through teams like, developers and infrastructure. Of the infrastructure team can be, or the business is best suited by the infrastructure team being honest and open with the developer team about, hey, the infrastructure can't do this, or it doesn't do this well. Can you make up for that? Can you compensate at the application layer? And vice versa. Hey, it's really hard, really complex, really expensive for this to do this at the application layer. Can the infrastructure do it?
Right.
And it's scary, right? Because oftentimes those teams are measured by very different things, right? Developers are measured by number of features added, by number of bugs fixed, et cetera. Infrastructure is measured usually by efficiency.
Right.
How
By
cheaply
uptime.
can how cheaply can I provide the minimum amount of resources to keep things running, and nobody complaining? So being open and honest about that is scary.
You've
and
got
it's
to
hard
work
sometimes.
together though, right? Like, and I have a talk about this, like heaven is not a cloud, right? Like it's important to bring in all the people at the table. And I mentioned in that talk specifically finance, because they know how to talk AWS better than you do, right? Like when it comes down to brass tacks and dollar bills, they own that piece. You got to bring in more than just dev and ops sometimes too, is a lesson I've learned.
I see JP Dade talking about the ramming speed in there, which I saw a post about CD Projekt Red, who their CEO swore up and down that they would never have crunch for releases, and they just announced that they're doing crunch. While I'm not, we have a relationship with engineering, and I'm aware of what they're going on there. I'm not aware of like a crunch happening inside of OpenShift engineering, very much to the answer that you provided in chat. Our teams work hard, they do their jobs really well, and it makes it when it makes it. And I think that there's a lot
Windows
of
container worker nodes. It makes it when it makes it.
It makes it when it's ready, right? So like we
like we're not going to put out like a crap product that doesn't work all, like we don't want to be the fail whale, right? Like we have to make sure things are fully baked.
The fail whale, I haven't seen, I haven't thought about
I froze you both with that one.
Wow. I think, going back to the application design, well, and I guess that's like the whole idea of DevOps, right? It's not necessarily like a department or like a thing. It's like how you work together, right?
A concept. It's a process.
Yeah, it's a process, right? Yeah, exactly. And I think also Eric, I think Eric's on the chat. Eric,
he was earlier, yeah.
Eric always says that OpenShift doesn't fix your crappy application design, and that's
it also doesn't fix your broken culture either.
Yeah. Well, I mean, that's true,
no
right?
offense.
Like you can't just like, I'm gonna buy this off the shelf, and he said it kind of abrasively, but I mean it's true. Like you can't buy this off the shelf, and then just like throw it at a problem, and then the problem just like magically goes away, right? So you do have to, and judging by the questions that coming through, it makes sense, right? Like how do I size this? Like these are the questions you need to like start asking, but it's more important, these are the questions that conversations you need to start having
internally,
just as an organization and just in general, right? Like how are we gonna,
and if
this platform is very powerful, how
do we fully utilize it? Yeah. So just to I'm going to post, I can't post screenshots in the stream. That sucks. But I'll post it on Twitter. That's fine. How about that? I am in the process of installing using the assist installer on my R820 across the house.
R820. Did you have to run the cable yourself?
I ran 3 cables actually.
Oh,
well, they're right above me.
Okay.
Well, I mean, it's not a finished basement, so yeah.
Oh well, because I thought you meant like in the tool shed. I imagine you outside with a pickaxe, trying to run fiber.
No, I'm not like Eric. Or our boss splicing together his own fiber that somebody else cut. That's just next level.
That was funny. Yeah.
Wow.
But it worked.
Yes, I could do that, but no, thank you. All right. So, Andrew, what else you got for us? Anything fun?
I know we're coming up on the end of our time together. So, have you talked about next week?
No, have not. Hour? What are we going to do next week?
So next week, the admin hour is not happening.
What?
What?
I know. We're all
how hard it is.
Disappointed.
No. Do you understand how hard it was not to have just morning routine wise, not to have Langdon's show last week, right? It broke my morning routine, right? And it kind of like threw my whole day off kilter, right? Like so you're telling me now I have to do this with you too?
Only once. Well, once so far. So the good news is something that I think is very relevant for the audience for the admin hour, and that is we are having the first of the OpenShift product management team presenting what's new in OpenShift 4.6. So
yeah. So this is actually the same thing that goes out to our sales and our solutions architects and our our product managers, our TMMs like me, our PMMs, the whole 9 yards. You're going to get it at the same time this month. 4.6, everybody learns what's new at the same time. This is now an internal meeting that we're opening up to the world through OpenShift TV.
And I think that's the big thing is like, this is usually a meeting we have internally. We are now having this public
externally,
right?
With everyone
now
at the same
whoever
time.
Whoever wants to watch can watch.
I'm pretty sure Chris is going to be broadcasting the Blue Jeans meeting. Right?
Yes, like I'm literally broadcasting Blue Jeans prime time. Yeah. It's the real meeting, folks. You will see our normal hold music and everything that we see internally all the time. Everyone here on the call knows what I'm talking about.
The on hold Blue Jeans music. That's
right.
Yes.
So importantly, for Red Hat folks who will still be joining the Blue Jeans, you can still ask questions. You can still do all that other stuff. The PM team and some others will be there to help answer internal questions, and there'll be a whole team of folks here on the live stream that will be doing the same thing. We'll be answering questions. We'll be transferring questions over
back and
into
forth,
internal chats and all that other stuff. So
I think the one thing to point out for our internal, like for Red Hatters, right? Like the Q&A thing will still be there in Blue Jeans for you, right? Like now
it will not be broadcast.
It will not be broadcast. So you will not, as the viewer, see the internal questions. That's the only kind of like firewall we're putting up in between here, right? Like I just want to give you the presentation. I don't necessarily want you diving into all the questions and answers. I want you to ask the questions and answers
not
as they apply to you, right? Like, right. Like,
we want to show you every skeleton, only some skeletons.
Because there's going to be some bespoke question about like a specific customer needs this kind of configuration. Is this being satisfied by this version kind of thing, right? Like, there's going to be questions like that. Y'all don't necessarily, they're not germane to you, right? Like, I don't want to show you that stuff. What I want to show you is the actual presentation, and I want you to be able to have questions answered. There'll be people here on OpenShift TV from the PM team to help us. I think the three of us, at least from the TMM side, will be here to help. Reese, I think you're presenting during that whole thing. So yeah, like everyone on this call is going to be here as part of that call next week. It's going to be super fun. I'm legitimately excited. Yes.
Yeah, I did not expect us to be broadcasting those calls, and I'm super
no, when that one came to me, I was like, hell yes.
That's right. This is awesome.
All right, guys, or gentlemen, folks, thank you all for joining. Coming up immediately after this, so that was next week, we'll have the What's New in 4.6 show starting at the same time this show started today, actually. Started at the 10 o'clock slot AM time Eastern, 1400 UTC. But coming up next is OpenShift Commons Briefing. Modernize your application development for OpenShift with Joget. It's Joget, however you want to say that tool. But Ravish Dewan will be joining us from Joget, or however you say it, which is a fun little Kubernetes tool. So yeah, should be fun.
And in 2 weeks, the admin hour will be back as regular scheduled. I've already talked with and confirmed with Richard Vanderpool, who will be our guest from CEE, joining us.
Very fun. I cannot wait. I always love having our support folks on.
Yeah, and also, right, real quick, if I may use this platform to
absolutely
kind of promote, I am starting a new series, right, a bi-weekly series called the GetOps Happy Hour, which will premiere October 8th.
Tomorrow.
Yeah, tomorrow.
No, next week.
It'll premiere October 8th and at 3 p.m. Eastern. We'll be talking basically every 2 weeks, kind of similar format. We'll be talking GetOps. We'll be bringing in a special guest here and there.
Yeah,
and,
I mean, bring your GetOps questions. Christian is the Kelsey Hightower of GetOps.
Yes,
right.
Yeah,
like I refer to him when it comes to GetOps questions. So
it's a big pedestal. So now I have something else.
You have large shoes to fill.
Large shoes to fill. If you're gonna say that, yeah. So October 8th, 3 p.m. Eastern. Every 2 weeks, I'll maybe increase that cadence if need be. But so come and join me.
Awesome.
So sorry Andrew, using your show as a springboard.
Oh no, that's fine. That's what we're all about
to
on this
promote
channel.
to promote my
You're
It's
doing
a
me a
shared marketing
favor.
budget.
Yeah,
That's right.
You're
Yeah,
doing me a
exactly.
favor by remembering to say it. So yeah.
Yeah, this we have a very small marketing budget, so we have to kind of
we got to plug what we got. Yeah. So
cool.
Narindev keeps hyping this up as it's a battle between Christian and I, and that could not be further from the truth. Christian and I actually march lockstep, hand in hand together through the GitOps realms.
Exactly.
Yeah, so this will be fun. So join us here in a few minutes for OpenShift Commons. Thank you for joining us today for this wonderful extended OpenShift admin office hours, and we'll be back next week with the What's New briefing in this time slot. So it'll be fun. We'll be there, and stay tuned. When in doubt, check out the if you want to try OpenShift, do what we did today, head on over to that try link that I just dropped in chat and subscribe to our calendar so that you know what shows are coming. And that's all we got for this show, and I'll see you here in a few minutes for those tuning into OpenShift Commons. Thanks, y'all.
All right. Bye, everyone. Have a good one.
Special thanks to Reese and Christian for filling in while I was delayed.
Yeah, so, they did a great job.
Great job, guys. I have no doubt whatsoever.